Hi, my name is Eric Kang, the Senior Program Manager in Database Systems at Microsoft. Today, I'm going to demo SQL Server Database unit test in DevOps pipeline. Let's take a look at how database unit test works in DevOps pipeline. And then I'll go through all the details of how it's made. The key components that I used in this demo is Slacker, which is open source database unit test framework. And another open source project that I use is Slacker Runner, which is for Visual Studio Test project integration, and it's a NuGet package. Of course, I'm using Visual Studio as my IDE, and SQL Server Data Tools SSDT in Visual Studio, which is the state-based database project system. And for CI/CD pipeline, I use Visual Studio Team Service as a control tower. The first demo is about how it works. As a developer in DevOps team, I want to enable continuous integration and continuous deploy on the whole project, including database. Also, I want to enable gated build in CI using unit tests. So if any unit test fails, then build should be failed. Let's jump into the demo. I'm going to use my demo application, which is AdventureWorks Directory Services. It is a web application service running on Azure, and it connects to SQL database on Azure for data. What it does is simply pulls down employee information from AdventureWorks database, show its employee detail, and renders org chart. Let's open our solution in Visual Studio. In Visual Studio Team Services, I have a project called the SQL Data Tools, which is my team project, and it uses Git as source control. Let's open our solution in Visual Studio. I have cloned my repository from Git to my local dev environment. So I'm clicking the solution file and open. The solution is being loaded up. For this solution, I have 4 projects. AdventureWorks is the database project using SSDT. You can develop your database in state-based approach. In state-based database development, you develop your database in source code. As you see, all your schema objects, tables, store procedures, and so on are captured in source code. And what you do is that you develop your code in source code and change the state of your database, then build, test, and publish your database projects to your target database to change your target database to the state of your database project. If you're not familiar with SSDT and state-based database development in DevOps pipeline, we have published 2 Channel 9 video recordings. Today, our job is to make our application more secure. As you see, we are showing all the employee details on the public web application. In our database, we have 2 users. It's defined under security folder, application roles. One is internal apps and the other one is public apps. What we want to do is mask any sensitive information from employee for public apps. But for internal apps like HR application, we want to show data without masking. For data masking, I'm going to use dynamic data masking feature that is introduced in SQL Server 2016, which is great that you can mask any data without changing a single line of code in your application. So let's go to email address, which is our code, the source code for email address table. And there, I'm going to mask email address. I have a sample code for this demo. So I will comment out the original code and then uncomment the change that we want to have. It is a really simple change with a masked with a function, an email type. That's it. The next step is save the file and build it. The SSDT analyzes all your source code and build a model, verifies if your change is correct and there's no error, produces artifact that is called the DACPack. Using the DACPack, now you can publish your changes to your target database. In this case, I have a published profile that I have made already, which is AdventureWorks unit test. The published profile defines connection strings to your target database, which is a unit test that I'm going to deploy into my local dev environment. I'm running SQL Server 2016 on my laptop, so I can deploy that and test. In SQL command variables section, I have defined one variable, which is deployment configuration. Only when deployment configuration is set to unit test, it deploys unit test user so that I can run a test on the specific database. Let's publish it. So if you take a look at the result, now you see that SSDT generates deployment script that contains all necessary changes for your simple change like dynamic data masking. Okay, now let's take a look at test parts. If you take a look at our solution, there are two projects that is called the database unit test and then test specs. Database unit test is regular Visual Studio test projects, and in that I have a common test method that runs all test cases. In this case, we call it test specs. The real test is defined in test specs project. This is a Slacker project. Slacker is an open source unit test framework for SQL Server database. It has many powerful features. The basic concept is that you define your test cases as Ruby RSpec format. I have two stored procedures that I use in AdventureWorks database, so I have created a unit test for each of those. Slacker provides most of test methods, that is scalar, value checks and comparisons, all that. One of the really useful feature of Slacker unit test framework is that you can very easily seed your unit test mock data using CSV, and then you can also define your expected value in CSV, and when test case or test spec runs, it automatically seeds your mock data to your database, run the test, and do the comparison against between those the results that you have and expected data CSV. For database unit test, being able to mock your unit test data is one of the most important feature that you need to look for. Let's take a look at one of our test case or test spec in the Ruby RSpec term. It is written in Ruby. The learning curve for Ruby language for Slacker framework is pretty low. It has test spec and test methods in it. I can have a single or multiple test methods in a spec. First, I call it the Ruby RSpec module, which is a function that seed org chart data. And then I call expect function. It runs a SQL statement, which is defined in sql.adventureworks.exe human resources USB reports file, passing ID value 1 and get the result. And then match it with our expected CSV data, which is what is defined here, and in asserts. Okay, then I'll show you the SQL file that I used in this spec. First, it's in the SQL folder, AdventureWorks, and as you see, there is 3 files. What I call in this test spec is this function. So basically it takes argument ID and set the variable business entity ID and execute the store procedure. That is the main logic of building org charts in my application. In this demo, I have defined 3 specs, and I just kept one sample test spec that came with the Slacker framework. Before we run the test, let's take a look at live and helpers. I have created one module that is called the seed data. For my application test, I repeatedly see the mock data for my unit tests. So instead of repeating, these are the seeding the mock data, I created a function in seed data module so that I can call seed orchard data repeatedly in multiple test specs. Now, let's run and see if everything is fine with our change, which was adding dynamic data masking in our code. Well, there was a failure. Let's take a look at it. Okay. The first failure is that the test was expecting email address in the unmasked form, but the result is masked, which was the change that we just made, and the test case was not updated with the new change that we have. So this is expected. This is a test issue. But for internal apps, the intention of our code change was that it should return unmasked data so that the internal apps can show the email without masking. So this is code issue that comes from our change of dynamic data masking. So let's fix one test issue and the code issue. I'll make Test Explorer smaller. So the test spec that returned the failure was execute as user test spec. If you see, for public apps, test spec was checking if the return value is the unmasked email address. So let's fix this one. So expected value in this case is this masked format. I'm gonna go and update it. Okay, and there is another failure in this case. When test runs as internal apps user, it was expecting the clear text unmasked format. So in this case, the test case is correct. Then it should be a code issue. So let's go to our code, which is our security and internal apps. So for internal apps user, we have granted permissions that is necessary to run the application. But with the dynamic masking, there's additional permission that we need to provide, which is, let me just copy, which is unmask permission. By giving this unmask permission to the user can still see the data without masking. That is the permission that we need for internal apps, which is correct change for internal apps. Through the unit test, we could discover this issue before it causes a runtime error on our application. Now, let's build it again. Okay, it should be done by now. And then publish it again. Okay, I'm publishing it to my local instance. Okay, it is done. So let's run unit tests again. All right, so everything passed with a change. So we have fixed the one test issue and the database code issue with the permissions. Great, I have enabled a new feature, dynamic data masking, and fixed one test issue and the code issue that is discovered by unit testing. So it is verified, and now it is time to check in my code. So in Visual Studio, the Git operations are integrated in Visual Studio, so I can just click this button, and let's name it as data masking fixed unit test, changed permissions on internal apps. Okay, so these are the changes that we did in our project. So let me commit it. Okay, it is done. And now I can go to here. Another action which is basically allow me to push my change to remote Git repository, which is in the VSTS team service. So let me push it. Okay, it is done. Let's take a look at the our project, which is SQL Data Tools, and click Build. And you notice that there is a new build triggered, and the 3 builds are in queue. Main reason that it is in queue is that I'm using my own laptop as a build agent. You can bring in Windows VM or any on-prem machine as build agent, or for this case, you can basically use the VSTS Teams, Visual Studio Team Services hosted agent, which has a limited usage if it in the free version. If you have a paid subscription, then you can use it for certain quota. Okay, so let me go to my own machine because I have set up my own laptop as a build agent. I go to cd agent, and there is a run command that starts my machine as a build agent. You can run it as a service, or you can run it on demand like what I'm doing. Once it starts, then the build will start again. Okay, as you see, the new build just started, which is using my machine in here. So let's take a look at what we have and what it means. So as soon as I check in, build started, which is done by Visual Studio Team Service and agent communication. So if you take a look at what had happened is that for gated build, which is what I'm showing right now, it first initialize job, gets sources from the agent gets sources from the Git repository, and then restore all the NuGet package that is required by solution, and then build database and run unit tests, and then publish the final result. If the unit test fails, then the entire build will be failed. That is the definition of a gated build. I will show you the builds that was done in previous. So if you take a look at it, there are successful build and failed build. If you go to failed build, it tells you exactly what caused the database failure. In this case, unit test failed while I was preparing for this demo. I experimented with multiple failures, and as you see, it shows the test results with its detailed information on the what portion of the test and code failed. So you can have a full history of your database build and the history of unit tests all in one dashboard-like interface. So now everything is successful as expected, and I'll show you how you can configure this very easily. So basically, when you create a new build definition, it starts with empty. What you can do is that add a task that you need to your build definition. For database build, get sources, NuGet restore, these are just the templates. And you don't have to change any parameter in there, except the AdventureWorks demo NuGet config file, which is a part of the solution. Build is basically doing MS build on the solution and the database project. There is one MS build arguments that you need to specify. This is kind of a template that you can just specify same way, except the profile that you want to use. Because as part of the CI build, we are going to do unit test, we are going to use the same unit test publish profile with the deployment configuration, which is set to unit test, so that the unit test specific environment can be set up correctly. And next task that you need to add is test task, which is also under here, test section. There is, let's say, Visual Studio test. That's basically what you need to add. Once you add it, then you will have this one. And there's no change that you make. Just use the default value, then it'll automatically find the test project in our solution and run the test. Likewise, what you saw in the Visual Studio. And the final step is after build is successful, then you copy the DACPAC or any SQL file that is necessary to deploy your database to target from build agent to server, which is what we have defined. So basically that's it. And to enable the CI, turn on the continuous integration and monitor the specific Git repository and the branch. In this case, I'm watching dev branch. So whenever there is a new check-in, AdventureWorks unit test CI build will be automatically triggered. Okay, another thing that I want to show you is about the continuous deployment. And if I go to release section, whenever there is the successful build, then release will be automatically kick in with its own workflow. So it has two cases. One is deploying the database and the solution to user acceptance test environment, and if so that we can do functional testing and user acceptance testing. And the production is the next step, and the deployment of production starts only there is approval from the user acceptance test. It is all the default functionality of Visual Studio Team Services, so you can play with Visual Studio Team Services, and then you can easily figure out these workflow orchestrations and setting up. For database deployment, there is also a task that you can add. So if you go to deploy, and there is Azure SQL Database deployment. If you are deploying your database against a SQL database on Azure, then just use this. If you are using TFS within the on-premises or databases in Azure VM, then what you can use is just a command line task with the SQL package parameters. I'll first show you the Azure SQL database deployment. After you add, what you need to configure is basically the connection string. If you note that the password is protected with a variable, so the password is not exposed for your test or even production. And next configuration that you have to provide is the location of a DACPAC file, which is you can just browse through and just select it. That's easy. Okay, and the last one is important because we have enabled conditional deployment for unit test, which deploys unit test login and user to unit test database. We don't want that in our user acceptance test or production. So in that case, you can provide a different deployment configuration value, which is not unit test. Then unit test specific logins and users and permissions will not be deployed to your production or user acceptance test environment. And basically that's it. So let's take a look at our application. Right. With the change, it went through automatic CI, continuous integration, and it triggered the automatic the continuous deploy, and now our application on user acceptance test environment is correctly changed and deployed. Now we can see email address on employee is correctly masked. All right, we've seen the live demo in action, and as well as how-to parts for Visual Studio, SSDT, state-based database project, and running unit tests, and as well as the CI/CD pipeline and how to configure that one. The last part that we want to cover is about the unit test itself. Okay, so let's go to our database unit test. As I mentioned, this is a Visual Studio test project type. So if I go to solution and add new project, and add new project, and go to test under Visual Studio, then there is a unit test project template. This is it. You start with this, and then it will create your test project. I named it as database unit test. First, the thing you need to do is go to references. There are a few references that is a NuGet package that you need to install. One is a Slacker runner and the XUnit. So I will show you. Go to references, manage NuGet packages, and browse Slacker. There's a Slacker runner. You install this one and search for unit test, XUnit, and you will see XUnit, and this is what I installed on the test project. Another thing that you need to install is XUnit runner, and scroll down here, XUnit runner.Visual Studio. Without this one, our test method and test classes will not be automatically discovered by Visual Studio, so it is necessary. And let me close this one. One thing that I want to show you is that this is just a common method that you can use it as template, just a copy paste. And one thing that you need to change is this, the directory information. This is basically pointing the directory structure, this one, of the test spec project in disk. So I will close down some of this. And if you see, the spec test cases are under spec folder. So you define this one. Rest of them is just a template. Okay, for the test project, that is it. So now let's go to Slacker. We've already gone through the detail of each test. Let's look at how you can enable Slacker environment on your machine. To set up Slacker, what you need to do is that the first install Ruby 2.2.6, and you can just use download it and use a silent installation by specifying the directory, installation directory. And you also need to install Ruby Dev Kit. There is a link for that one. And once it is downloaded and extracted to, let's say, Ruby Dev Kit folder, then in the folder, you run two commands, rubydk.rb init and rubydk.rb install. And then on the command line, you run gem install Slacker. That will basically enable Slacker environment for your machine. Okay, so to create a Slacker project, what you need to do is that you just run Slacker _ new test specs in your solution folder. Then it will create the Slacker project structure, which contains data folder, live folder, spec SQL, and database YML. The last step you need to do is that to open up database.yml and specify the server database login properties, connection properties for your unit test database. That's basically really simple steps that you can enable Slacker runner on your test project in Visual Studio solution and run it and pipe it into your CI and CD. Thank you for watching the demo today. I have listed useful references. The first one is Slacker open source project and another open source Slacker runner. These two open source projects contains all the necessary information that you can get up and running for the Slacker unit test for SQL Server database. For SSDT and SSDT with CI/CD pipeline, you can watch 2 SSDT channel 9 sessions. We have part 1 and part 2. Both covers SSDT and all the DevOps pipeline in a comprehensive way, and each of these session also has follow-up references, so you can learn more from there. Thank you.